Good morning, everybody. Happy Monday morning. I hope you guys are doing well. Hope your families are doing well. So we had here just a little review from what we did last class. Remember that we're doing angle relationships with parallel lines. So if you're looking at the title of today's lesson, you'll notice that it looks familiar to last lesson, but I switched the input, right? I switched the hypothesis and the conclusion. So a fancy way of saying what we're doing today is today we're going to be looking at the converse, right? So I know you guys are like, why are we learning this stuff? Well, there you go. Stuff that we learned keeps coming back, right? So today we're going to be doing the converse of what we did last class. That is, we're going to be switching the hypothesis and the conclusion. So last class, and as you can see, I'm frozen here. Last class, right? We were given parallel lines and then we used angle rules. This time, we're going to use angle rules to prove parallel lines because a lot of times, especially in construction, that's what we're trying to do. We're trying to show that our lines are parallel, okay? And so that's what we're going to be working on today. It's very useful stuff. So again, as always, if you guys have questions, make sure to use the chat and to turn on your mic. And also remember, guys, to make sure that you're turning in your homework. It is 80% of your grade. If you guys need help, please send me an email or come to my office hours. This morning, I did send everyone and their parents, if they're signed up, with an email talking about making sure you guys are checking Skyward to make sure your grades are in. If you haven't taken the midterm, to email me and contact me, and that my office hours are changing because of coaching, okay? And as always, if you guys have questions, please let me know. All right, let's go over this warm-up. So in this warm-up, it says, given that the measure of angle 8 is 72 degrees. So this one right here is 72 degrees. What we're going to do is we're going to go ahead and then find the measure of all of the other angles, right? So measure 11, angle 1, angle 3, angle 6, and angle 5, right? We don't know why they're named like that. We're just switching it up. Okay, so I just want you guys to know that all of our answers should be the same, but how we got there doesn't need to be the same. Okay, so again, there's more than one right way to get to the ending. What matters is that we are getting the same answer and that our angle rule justifies what we did. So for example, if angle 8 is 72 degrees, I would just start locally, right? Start within your city. If angle 8 is 72 degrees, then I know that because I have two lines crossing, angle 8 and angle 10 are going to be the same. So I'm just going to start there and say, hey, angle 8 and angle 10 are both going to be 72 degrees because I know that is vertical angles. Okay? So I got 72 degrees, vertical angles going right there. Okay. Now, again, staying local, just in my city, that leaves 7-Eleven. Ha 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 ha. So we got to figure out how we're going to get there. Well, if I look at 7 to 8, they're both on a line, right? That's going to be a linear pair, and 8 and 11 are going to be a linear pair. Now, I could do a linear pair for both, or I could just do a linear pair for one. So if I do a linear pair here, I'm saying angle 7 plus 72 degrees equals 180 degrees. So all I have to do here is subtract 72 from both sides. So what I'm going to do in my calculator is I'm going to take 180 and I'm going to subtract 72. So I get 108. So angle 7 would be 108 degrees, and I used linear pair. Okay, and again, our reasons could be different, but what's important is that you're getting these answers and you're putting down the reasons. Okay. And then once I know 7 is 108, I can see, 7 and 11, those are vertical angles. So I can go, hey, 108 degrees because I used vertical angles. Maybe you used a linear pair or something else. Okay, but that's what I used. Okay, and that's where you're going to get individualism within math, right? There's more than one way to get there. So now, did you guys notice that these lines are in fact parallel, right? They have that little extra arrow there. So now I'm going to be able to connect my cities. And the easiest one to do is corresponding angles because it's location based, right? The upper left goes with the upper left. So if I take a look here at 7, that's the upper left. So then that's going to go with 1 here, the upper left. So if angle 7 is the same as angle 1, that would mean this is 108 degrees. You guys notice how I'm putting units on all of my answers? You have to put units on your answers as well. It's important, 108 degrees. So I'm going to say if parallel lines, right? That's what we started with. So we had parallel lines. You see how the order really matters? Because we're going to learn the opposite today, right? So if parallel lines, and we do, we have parallel lines, then corresponding angles are congruent. And it's important to note, we're going to talk about this today. The conclusion is always what you say, right? So the conclusion is always what we're saying. Okay, so notice how we're concluding angles are congruent, and that's what this is saying, is that angle 1 is the same as angle 7. Okay, and then, you know, really, I could just do corresponding angles for the rest of these, right? Because I started by finding everything in my city, so then I could just do corresponding angles. But I'm going to switch it up. So for example, I noticed that 8 and 6 are alternate interior. So if I look at 6, I know that's going to be the same as angle 8. So that's 72 degrees, because if parallel lines, and let's check, yep, I have parallel lines, then alternate interior angles are congruent. Okay, and then for 3 and 5, again, I could do vertical angles here. I like vertical angles. They don't require parallel lines, so I kind of like them. So 3 is the same as 6, right, because of vertical angles. And I'm all for writing less too, right? Okay, so I have vertical angles. And then 5 is the same as 1, right? And that's vertical angles as well. So here I used linear vertical, corresponding alternate, and vertical. Again, you guys could have used alternate exterior. You could have used consecutive interior, right? There's lots of them. And there's no requirement for what you have to use or not use unless the problem tells you. Okay. So that's just a little practice with what we learned last class. How you guys doing? We doing okay with this? Does anybody have any questions or comments? Sweet. I'm glad that this is working out for you. I know online learning can be hard, guys, so I totally get it if you are confused or stumped. So just make sure if you guys are confused or stumped that you send me a direct message or you email me. Better to do it now so I can help you, but make sure you let me know so we can get through that. Okay? All right. So today we're going to learn about the converse rules for parallel lines. So we're going to learn the converse rules to prove lines parallel. Okay. So that's what we're doing today. We're going to use the converse rules to prove lines parallel. So if you don't remember, we got to remember, converse means switch. Okay, so we're going to switch. So remember, we switch P and Q. So all we're going to do is we're going to take the rules that we learned last time and we're going to switch them. So I'm just going to write this again. So these are our converse angle rules. Okay, and what they are is they're gonna take everything we learned last class and switch the beginning and end. Okay, so I'm gonna have if corresponding angles are congruent, then parallel lines. Okay, so there's one. So if corresponding angles are congruent, then parallel. And again, we don't have a lot of time in class for me to prove all of these to you or set these up or do anything proper. So at this point, you're just taking my word for it, and I'm really sorry for that. That's not what math is about. Math is about being able to do it and have it make sense. I'm going to sneeze. I'm really sorry about that. So And we'll talk about what this conclusion means. We'll just make the list and then talk about everything, okay? So I have if corresponding angles are congruent, then parallel lines. Thank you, I appreciate that. And then I have if, right? We're always going to start with if alternate interior angles are congruent. We're using a lot of symbols, huh? Then parallel lines. Right? So do you guys see how we're kind of flipping the script, right? The converse is we switch the hypothesis and the conclusion. Okay, so then what else do we have? If alternate exterior angles are congruent, then parallel. Okay, so again, we're just taking these properties that we learned last class and we're switching them. We're doing the converse. Okay? And then the last one that we're going to do for right now is if consecutive interior angles are right? Supplementary, then parallel. Okay? Sorry for all the writing, guys. We're just going to get these down and have them in our notes so that you can always access them. Okay, so I know some of you are still getting this down. Some of you have them down. What I want you guys focusing on is what matters here is the conclusion, right? This stuff is stuff we're looking for, but this is the conclusion. What happens? It's like the so what. So what I really want to point out is all of these right here, right? Conclude that we have parallel lines. And so that's what we're going to be working on today, right? We want to have, given a situation, given angles, do we have parallel lines, right? And what these are saying is, if any of these are true, then yes, we have parallel lines. So in construction, if I want to have parallel lines, all I have to make sure then is that corresponding angles are congruent. And as long as corresponding angles are congruent, I have parallel lines. And one really easy way of doing that in construction is if the angles are both 90, right? Because if the angles are both 90, then there we go. Corresponding angles are congruent. But as some of you guys have seen, not all houses are rectangle boxes, right? Houses have angles and they have shapes, and we often think that houses that have more angles and weird shapes, the more beautiful they look. So and then same as with construction, you can make everything in your house be a rectangle, but a lot of people think that's boring. They want curves, right? We think curves are beautiful. We want triangles. We want, right, these different shapes that come with all these unique angles. And so that's what we're going to be doing today. We're going to be proving lines are parallel. That is, if these are true, then the lines have to be parallel. Okay? So we're going to start basic, and then we're going to work our way to something a little bit harder. Okay? And in your homework, you're going to have a little bit of everything. You're going to have some basic stuff, and then at the end, you're going to have a couple of more of open-ended proofs that you're going to have to take a look at. Okay? And explore. All right. So the first thing we're going to do, sorry, just going to bring my book over here, is we're just going to do a basic algebra problem of, and this is, think of this as construction. We want to make the lines parallel. Okay? So let's say I have, so here's an example. Let's say I have, boom, boom. I have these. Okay, so I have two lines. Oof, that bottom one's not looking so great. And it's M and N. This kind of looks like an Amazon line. All right, so, and then I'm going to have a transversal going through them. And then I'm going to label this top one, I'm going to label this 3x plus 5, and then put parentheses around it with a degree symbol so we know it's an angle. And then I'm going to put a 65 degrees right down here. And then what we're going to do, okay, so first off, in chat, because I always want to make sure you guys are paying attention and see if we're learning things. Are lines M and N parallel as shown? Can you guys just type yes or no? So are lines M and N parallel as shown? Ooh, guys, I think we're making progress. I think I'm making progress, right? They're not parallel. Now they could be parallel, but we don't know. Okay? Because there's nothing that tells us they're parallel. So what we're going to do is we're going to find the value of x that makes line M parallel to line N. Okay? So, now, this isn't much different than what we're doing, what we did last class. The difference is it's going to be our reasoning. It's going to be our logic. Okay? So, this is what we're going to do. So, what we need to do here, right? I have my list. I have my picture. If these lines were going to be parallel, do you guys see how these are my conclusion? Then one of these has to be true. You guys seeing what I'm saying here? So if these are going to be parallel, one of these has to be true. So let's take a look. You guys can type this in chat. What angle relationship do we have here? Because it's got to be one of these, right? It's got to be corresponding, alternate interior, alternate exterior, or consecutive interior. Ooh, the answers are just flowing in. It's like someone broke the dam of truth. Whoosh. You guys didn't think you were going to get spirit fingers today, and you did. All right, so yeah, these are corresponding angles, right? So what I can do, now this is really important, these lines aren't parallel. Okay, you guys told me that. You guys agreed with me on that these lines are not parallel. So I can't say if parallel lines, then these are congruent. You guys see that? How that's important? I can't say if parallel lines, these are congruent. So what I'm going to have to say here, I'm going to go 65 degrees equals 3x plus 5. And for my reason, I'm going to use the converse. I don't know why my voice cracked there. I think I've been through puberty. So I'm going to have 65 equals 3x plus 5. And I'm going to say, because if corresponding angles are congruent, then parallel lines. Okay? I have to use this one because I'm not setting them equal because they are parallel. I'm setting them equal because I want them to be parallel. And that is a huge distinction, right? I am solving for x to make them parallel. So we have to say if corresponding angles are congruent, then parallel. So I'm going to make them, I'm going to find x to make these congruent, right? So if we go to solve, right, then I'm going to subtract 5 from both sides. I'm going to get 60 equals 3x. And then I'm going to divide by 3. And I'm going to get x equals 20. So what does this tell me? If we make x 20, then the angles are congruent, and then the lines are parallel. Okay, that's it. That's what's going on. Okay, so we're saying if corresponding angles are congruent, then the lines are parallel. And that's different than saying if parallel lines, because these are definitely not parallel to start with, right? So if x is 20, right? So you can even write it as a statement. So if x equals 20, then m is parallel to n, right? And this can kind of be our statement there. That's how you would say it in the real world, right? So if we make x equal 20, then those lines are parallel. So if you're building something, right, this is something you would calculate. Be like, okay, if I make this cut and this cut, right? And the weirder the angle, the more unique and beautiful we usually find it, right? So yeah, all my woodworkers out there, what? Or if you're building a garden bed, or you're trying to fix something, okay, that's what's going on. Those are the basic, right? You get more advanced and you're designing circuitry and stuff. All right, does anybody have questions about this? Again, this should look really familiar. The only thing that's changing here is our reason. Instead of saying, hey, the lines are parallel so I know they're equal, we're setting them equal to make them parallel. It's a small difference, but it's really important. Okay? Because I can tell you some people are going to make mistakes on their final, and for those of you watching YouTube in the future to study for your final, okay, you're going to make mistakes because you're going to pick the wrong one. Okay, so make sure here we're saying the lines are parallel. That's our conclusion, right? So we put the parallel at the end. Does anybody have any questions about that? We doing okay? That's going to be our entry-level stuff. So you're going to have, I think you're going to have a couple of questions on your homework where it's just like, hey, solve for x to make these lines parallel. So you're going to be like, okay, are they congruent? Are they supplementary? You're going to pick which one it is, find x that makes them so, and then the lines are parallel. Okay, so it's kind of a construction piece. All right. So what I want to jump to then is the more, I want to spend time on the more, because that's just basically what we've been doing, but changing how we say it. What I want to spend time on is more complex proofs. Okay, so this is proving lines parallel, and I'm going to call it the hashtag. Oops. Hashtag. Why am I hash is HAS tag? Oh my gosh. The hashtag problem. Okay? So this is a type of problem that shows up, and it's the hashtag, right? The hashtag, remember, hashtag is like a pound sign. Okay? Your generation has used it as a hashtag. Okay? But it's before your generation, it was called the pound sign or the number sign. It's weird how one symbol has so many different names, right? Okay, so what we're going to do is we're going to look at this problem, and we're gonna so this is going to be a little bit more complex problem, and we're going to use this to prove lines are parallel. Okay, so what I'm going to do, and I wasn't joking, we're going to draw a big hashtag to the best of our abilities. All right, I feel like I have a Bob Ross moment here. Beautiful little hashtags. Right? And if everyone in class is drawing this down, you could say that this is trending. Okay. So we're going to go ahead and label these lines. So the top right is going to be R, and then S, and then P, and then Q. That was a really interesting cue, Mr. Kraft. I never draw my cues like that, and so I apologize. Here, I'm gonna. That's how I draw my cues. All right. All right. So we have RSPQ. Okay. And then I'm gonna add in some information. So we know that line R and S are parallel. And then the way that this book does it is it gives you some hints. So it's going to be like, you're going to want to focus on angle 1, angle 2, and angle 3. And they do this because if it was completely open-ended, it would be kind of overwhelming. So this way, when we get the problem, you only have to focus on 3 angles. And that's just to help you out, right? Like in real life, you wouldn't have someone be like, hey, look at these 3 angles, right? You'd have to figure that out. But to get started, I'm just going to have you guys focus on 3 angles. Okay? Now, there's some additional information here. So we're going to have a given. Okay? So here's our givens. We're going to have R is parallel to S, and angle 1 is congruent to angle 3. Okay, so we're just writing this down. And then what we want to prove, that line P is parallel to line Q. Okay, so the reason why I like doing hashtag problems is because it uses both what we learned last class and what we're learning this class. So it brings everything together. So it's really, really great practice on doing this stuff. Now we're going to do a 2-column proof together. And we do this for a couple of reasons. We do this to stay organized. And also it's a really clear way of communicating. Okay. All right. So we got in one column, it's going to be our statements, and then our second column is going to have our reasons. Now, let's see if you guys remember how to do these. What always comes first in a proof? What do we always start with? Yeah. At least one of you guys know this. What else? Hey guys, I need more people. What do we always start with? Are people not typing because they're like, Mr. Kreff, why would I type that? It's given that you start with the given. Right? You start with the given. You guys are 100%. You guys make me feel really proud. This is awesome. So I have 2 givens. So I'm going to write both of them in their own line. And we write them on their own line because we want to not miss anything. It's so easy to miss things, you know? So R is parallel to S. That's given. All right, 2. What's our next thing? Angle 1 is congruent to angle 3. Okay, that's given. Okay. All right, so now let's take a look at our diagram. We want to make sure all this stuff is represented in our diagram. Now, I already went ahead and said that R is parallel to S. So that shows up in our diagram. Okay. But what doesn't show up in our diagram is that angle 1 is congruent to angle 3. So I'm going to go ahead and add that. Okay, so this angle and this angle are congruent. Okay, so then, and that's always where you start, right? You write down your given, and then you make sure that your diagram has all your givens in it. Okay, that's all we're going to do. So write down the givens, make sure everything is in the diagram. Okay, the next thing we're going to do is we're going to look at, okay, what the heck are we trying to prove? I'm trying to prove P is congruent. I'm not congruent, parallel to Q. Now, on our last page, do you see how down here, we just wrote down all of these ways to prove lines are parallel. So we're going to have to end with one of these. This is our ending, right? We want to show, because we want parallel lines, we have to show one of these is true. Okay, so I'm going to go back to here. So we have to show an angle rule is true in order for these to be parallel. So then what we need is we need an angle that's on P, an angle that's on Q, and they have to be an angle relationship. So what angles are in an angle relationship? And I need to have one angle on line P, right? So look, so here's line P. I have to have one angle touching line P, and I have to have one angle on line Q. And the angles have to have a relationship. So what do you guys think? What angles should we look at? I need an angle on line P, and I need an angle on line Q, and there has to be a relationship between them. What angles should I look at? What do you guys think? So I need an angle on line P, I need an angle on line Q, and they have to be an angle relationship. So what 2 angles are we going to look at? Right? This is part of the proof. You have to make a plan, right? So if I'm going to prove those 2 lines parallel, what 2 angles do I need to look at? Okay, so not what reason. I want to know what 2 angles would I have to look at. Right, guys, all we're doing is we're trying to figure out, hey, I gotta prove these lines parallel, right? So I know, and then I want to go back on this, right? We have 4 ways to prove lines parallel, right? It's either got to be corresponding, alternate exterior, or consecutive. So what 2 angles, and they have to be one on line P, one on line Q, what 2 angles are we going to look at? I have 33 students. I should have 33 answers. Come on, guys. We're wasting time because people, right? You guys can type into chat. You can type in two numbers. I know you can do it. You can save time and just use a comma if you would like to. Okay, I'm still gonna wait because I don't even have 10% of the class responding yet. We're just wasting time, guys. Okay, we're getting some more people. And again, you don't have to do it to everyone. You can just do a direct message to me as well. Okay, so in this, one thing that we did really well is people recognized, right? If I cover up line Q, there's only one angle on line P, right? That's highlighted for us, and that's 3. So everyone got that right. We have to get angle 3 in here, right? But then there was disagreement about whether we want to look at 3 and 1 or 3 and 2. So a lot of people said 3 and 1, and we already know something about 3 and 1, right? 3 and 1 are congruent, aren't they? Okay. But is this an angle relationship? Are these corresponding angles? Right? And if we look at them, are they even connected by a transversal? So if we look at what cities they're in, angle 1 is in this city down here, and angle 3 is in this city up here. Are those cities even connected? Right? So take a look. Is this city down here connected to this city up here? They aren't they? To get from 1 to 3, I'd have to go through a different city, wouldn't I? So angles 1 and 3 aren't connected, right? So they're not going to have corresponding angles. They're not going to have anything. So 3 and 1 can't be angles that we can use to prove those lines parallel because they're not connected, right? There's not something connecting this city to this city. Okay, so if I can't use that, what's next? What about 3 and 2? Well, do you see how they have a transversal connecting them? Angle 3 is on line P. Angle 2 is on line Q. And in chat, is angle 3 and 2, are they an angle relationship? What angle relationship would angle 3 and angle 2 be? What angle relationship would angle 3 and angle 2 be? So we wrote down some angle relationships. What angle relationship would angle 3 and angle 2 be? So if you guys are stuck, the list, right? Yep, that's good. So yeah, okay, some people are getting it. Remember, the list is in your notes, right? So it's got to be one of those 4, right? There's only 4 angle rules that it can be. So it's either got to be corresponding, alternate interior, alternate exterior, or consecutive interior. All right, so you guys are starting to get it, right? Angle 3 and angle 2, they'd be alternate interior. See how they're inside P and Q, they're connected, and they switch sides. So this is alternate interior. So I just want to stop there. Do you guys see how that took a bit of work, didn't it? So I got my given down, and then I'm looking, okay, I got to find an angle on P and an angle on Q, but it can't just be any angle, right? Because this isn't an angle relationship. And if it's not an angle relationship, it doesn't prove the lines are parallel, okay? So then we look at these two. This is an angle relationship. And if I look at that, if alternate interior angles are congruent, then they're parallel, okay? So when we're doing proofs, it takes a lot of planning before you do the problem, right? So we know this is how we're going to end. We're going to end with if alternate interior angles are congruent. That is, if angle 3 and angle 2 are congruent, then these lines are parallel, okay? That's what is going to be key there. Okay, so how are we going to do that? How are we going to show angle 3 and angle 2 are the same? That's our problem. But if we can show that these two angles are the same, then these two lines have to be parallel. And I want to stop there before I move on. Does everyone here understand why I'm saying this or understand what I just said? Do you guys, does it make sense that 3 and 2 are on lines P and Q, and they're the only angle relationship. So if they're going to be parallel, this has to be true. Does that make sense, guys? Right? So if I'm building something and these are going to be parallel, the only way I have knowing that they're parallel is if these two angles are the same. So that's my goal. I need to show that angle 3 and angle 2 are congruent. I know it says prove this, but that's really what I'm trying to prove. It's like my side quest in a video game. I can't get to the final quest until I do my side quest. All right. So I need to show angle 2 and angle 3 are congruent. Well, I can't use alternate interior angles because P and Q aren't ready yet. So I only have one pair of parallel angles, or parallel lines. So if you look at this, do you guys see how R and S are parallel? Well, angle 2 and angle 1 are in R and S. Is this an angle relationship? You guys tell me. Is this an angle relationship? And if so, what angle relationship? So is this an angle relationship? And if so, what angle relationship? Yeah, it's corresponding, right? So, and take a look. Do you guys see how these lines are parallel? If these lines are parallel, then what do we know about corresponding angles? They have to be congruent. So I would know angle 1 would have to be congruent to angle 2. And my reason would be if parallel lines, now see how the parallel lines comes first, right? So if parallel lines, then corresponding angles are congruent. Notice how my conclusion is what I'm saying here. See how I'm saying corresponding angles are congruent? That's my statement, right? So if parallel lines, and that's what we got there, then angle 1 and angle 2 are congruent. It's going to do multicolored there. Okay. So again, if you're confused, please say something now so I don't go on and confuse you more. Okay. So what I'm saying here is I want angle 3 and angle 2 to be the same, but I know angle 1 or 2 are the same because if these lines are an S, right? And maybe I can write that underneath it. Right? So if parallel lines, and we have R's parallel to S, then corresponding angles are congruent. Now you might be like, well, Kreft, you said we were trying to prove angle 2 and angle 3 congruent. Well, check this out. What does angle 1 equal? 3. What does angle 1 equal? 2. Okay? So then we can say if angle 1 is the same as 3 and angle 1 is the same as 2, angle 2 and angle 3 are congruent. Does anybody remember why we can do this? What's my reason? It's an algebra reasoning, right? If 1 equals 3 and 1 equals 2, and it starts with an S, what can I write? What's my reason? You know what? The chain rule is absolutely the right idea, right? Because that's what we're doing. So I will take two answers here, but technically the more correct one starts with an S. But yes, you're absolutely right. If you wrote down chain rule, I know what you're doing. And that's right. I would say substitution. Right? This is like y equals something, and then you use substitution to eliminate them, right? To do that, substitution method. Now, if you also said, because someone said chain rule, if you said transitive, I would give you credit, okay? And transitive is the chain rule, okay? So I totally get what you were saying with transitive. And with your midterms, if you guys wrote, like, for example, if you wrote any three of those, I would have given you full credit. Okay? But the correct one, the one I'm looking for, is substitution there. Okay? All right. Wait, hold up. Man, everything's going so fast in our first proof together, right? So you're telling me that we found angle 2 and angle 3 are the same. Well, what did we say before? Angle 2 and angle 3 are alternate interior angles, right? That's what we said. Well, what happens if alternate interior angles are congruent? We have parallel lines. And I just want to go back to that. This is our new thing, right? So we're saying the converse. So if alternate interior angles are congruent, then we have parallel lines. Well, guess what we just proved? Alternate interior angles are congruent. So for my last thing, I'm going to say P is parallel to Q, and my reason is if alternate interior angles are congruent. And do we have this? We sure do. We just said it right there, right? These are a pair of alternate interior angles, and they are in fact congruent. And then I say, then parallel lines. And that's exactly what we said here, right? So our conclusion is our statement, and we have to make sure that our hypothesis happened, right? Or else we can't use it. All right, so there you go, guys. You guys just did your first complex proof. Okay? Now, if you're like, man, that was confusing. Man, that was really different. Yeah, it is really different. It's not algebra, right? It's geometry. So it's very different, and it's going to make you feel uneasy and uncomfortable because it's something that you're not used to doing. Okay? But to break down what we have, you're always going to have a given. And then you're going to have true statements. Oops. T-U-E, true statements. And then you're going to have what you're trying to prove. Okay, so proofs will always come in these three sections. You write down your given, then you're going to have to write down some true statements, and from those true statements, you're going to get what you're trying to prove. Okay, and that's kind of the flow of proofs. There is no formula for proofs. There is no, right? Because now that we've proven this, we should never have to prove this again because it's proven. Okay. It's 10:51. I don't really have a lot of time, but I want to do one more of these. Okay? Because the only way to get good with proofs is to get through that awkward phase, to get past the first date. You know what I mean? Like the first date is awkward. So we want to get past that. So I'm going to do one more of these with you guys, and let's see if we can, if not understand it, maybe just take a little bit more, right? It's kind of like... no, that was a weird analogy, so I'm not going to share that. Okay, so let's do one more of these and see what we can do, okay? So, again, draw a hashtag. We're going to switch up this problem just a little bit, right? So a hashtag is 4 sets of lines. We're going to, I'm even going to call them the same lines. We have R and S, and we have P, and we have Q. And to help you out, we're only going to focus on 3 angles. So we're going to focus, I'm going to change where those angles are, so be careful. Okay. And we're going to have a given. And our given is going to be P is parallel to Q. And we're going to prove, oops, nope, I have one more. And angle 1 plus angle 2 equals 180 degrees. Those are my 2 givens. Okay. We're going to prove that R, oops, let's do this in blue. We're going to prove that R is parallel to S. And again, we're not doing like the cool real world stuff yet because we're just doing this stuff so that we can get used to the rules, used to the format, right? We gotta start somewhere, and this is where we're starting. This is a good place to start. So I'm trying to make sure you guys have plenty of time to write this down, but I'm also conscious of the fact that it is 10:54 right now, and that this class gets out at 11. So I'm trying to balance between having you guys have enough time and getting through this, okay? So the first thing, we always start by writing down our givens. So I know P is parallel to Q. And then I also know that angle 1 plus angle 2 equals 180 degrees. Okay, so I have 2 givens. Now the next thing I'm going to do is I'm going to update my picture. So it says P is parallel to Q. So I'm just going to add in that extra arrow that wasn't there, right? So I know that these 2 lines are parallel, but not R and S. That's what we're trying to prove this time. Now, I don't really have any way of showing angle 1 and angle 2 are supplementary in the picture, so I'm just going to have to remember that in my head. Okay, so now we're going to have to find true statements. So I want to prove R is parallel to S. So I take a look. Well, I only have one angle on S, so it's going to be angle 1. So then I got to figure out, okay, well, angle 2 is down here. Angle 2 and angle 1 aren't connected. You guys see how the cities aren't directly connected? So it's not going to be angle 2. So I'm going to be looking at angle 1 and 3. Can you guys type in chat really quickly? What angle relationship are 1 and 3? They're not corresponding. They're both on the inside. Yeah, they're consecutive, right? So, right, they're consecutive interior angles. Okay, so I might go back and take a look at my notes, and I see, okay, if I want to prove lines are parallel, then I have to have consecutive interior angles are supplementary. Well, that's really good. I have a 180 in here, right? But I don't want 1 and 2 are supplementary. I want 1 and 3 add up to 180. So if I can show that angles 1 and 3 add up to 180, then I know these lines are parallel. Okay? So then we're going to have to come up with some true statements. So I'm really close here, right? I have 1, but I want 2 to be 3. So let's try to see if we can replace 2 with 3. That is there an angle relationship between 2 and 3? Well, 2 is also on line Q, and 3 is also on line P. And I know those 2 lines are parallel, right? So if those are parallel lines, can I say these 2 angles are congruent? So in chat, what do we have really quickly? What angle relationship is this? 2 and 3. Because they're on parallel lines. Yeah, Alt-Int, right? There you go. So I'm going to say then, hey, angle 2 is congruent to angle 3. And the reason for that is if parallel lines, right? And I do have parallel lines, right? P and Q. Then alternate interior angles are congruent. So again, do I have parallel lines? Yeah, I said that right here in my first line. And then, am I saying angles are congruent? I absolutely am saying angles are congruent. Okay, so I can update this now. Angle 2 and angle 3 are the same. Well, just like our last problem, I want, we're going to do a little combination now. I want 1 and 3 to add up to 180. So my next step here is I'm going to say, okay, I'm going to replace 2 with 3. So I'm going to say angle 1 plus angle 3 equals 180 degrees. And my reason there is substitution. Right? And if you write transitive, that's going to be okay. But the correct one, right? Because you're going to be doing book homework, and there's definitely a correct. So substitution and transitive. And remember, you get unlimited guesses in the book homework. So if you guess one, just guess the other. There you go. All right. So, boom, check this out. I have what I wanted. Angle 1 and 3 add up to 180. Okay? So then I can go ahead and write my last step here is, hey, these lines have to be parallel. And my reason for that is that if consecutive interior angles are supplementary, then parallel lines. Now, let's double check. So these consecutive interior angles are supplementary? Heck yes. And then, am I concluding that they're parallel? Heck yes. Okay, I would put a box there and say, hey, we're done with this proof. Okay, your homework is going to have a little bit of everything, but I can tell you right now, it's not going to have any problems this complex. it's going to be less complex. Okay, so I know some of you are like, okay, I feel a little overwhelmed. This is really new. We don't have a lot of time. But it's okay to be uncomfortable. It's okay to be a little lost. You guys are just going to try. And if you guys need help, all you need to do is email me or join